Welcome to that third and last part describing the computational fragment-based protocol. It is using data which are available for download for free trial on the MED-SuMo website. So this is where we were at the end of the second video. We ended up with 31,000 hybrids which are here. And there are two things I would like to show you is to search into libraries, two things. The first one is to search into a library of compounds which are non-actives for EGFR. So the matches of those hybrids which are in 3D on those 2D molecules in chemical library that will result, if there is a hit of course, in the determining the 3D pose of those active compounds. So to do that, we just go to the tools and search wizard, and that will use the input tab molecules. That's fine. We select the target molecule. We use a file from Campbell, the target 203, which is EGFR, the one of 1xkk PDB file, and there are something like 5,000 non-actives. So I will just use that file. Those molecules were aromatized. This is very important because it's not done by default in the software, so you should aromatize the molecule. And then you define an output file, which we will just give a name, which is this one, and we add the word matches. We save that, and we just remove that find multiple match per query. One match is enough, and we can just launch that. We go to next. Well, that will search. That's using a multicore if you have on your desktop. And the dummy atoms that are shown here, you see the stars atom, that they will be used as wildcard. They will match nothing or atom. They are actually coming from the fragmentation, the original fragments. So they are still here, and they indicate position where there were an existing bond in the former fragment. So that's interesting to keep that, because that's at least it was possible with those original ligands or fragments to have a bond here. And we just launch that and we press start. And I will just stop the recording in the meantime, because this search is taking some time. Okay, this is almost finished. It took a few minutes. I will, in the meantime, well, that's finished, but we can display all the matches in the molecule grid. It's 194 matches. That means the hybrids which are contained in the Campbell file of molecules which are annotated as actives, and we can display them. And we have now, you see on the right side, some compounds which are from EGFR, which are non-actives. Well, we can select a few of them just to show you that they are in 3D. I can take those 10 first one and visualize them in 3D. And I can add the context. Then you see you have those hybrids which are generated in 3D in the binding site. You can switch them on and off using this tree view here. This is the query ligand that could be skipped, and for instance that one. And you can notice that the poses are generated and are relevant according to the target. So that's the first thing we could do. And there is a second search that I would like to show you, is that I would like to answer to one question, is there are maybe compounds here which are not similar to non-actives, and so we can actually search them. And to search for the compound which are not similar to non-actives, we can go to the hybridize menu, again the filtering rules editor. We remove those rules, and we add a similarity filter, and we take again those aromatized Campbell compound, and we ask them of not being too similar to them. So that's just a cutoff of Tanimoto of 0.85 using some fingerprints. There are other fingerprints available, but that one that will do. And we just click on Add and click OK. Just check if it is fine. Yes, we have the filter. And then we can apply this filter not only during hybridization, but also we can apply that here. So I will do that. And I will stop the recording for a while. Okay, we are almost finished with that filtering. So now we have on the right side, we have some 30,000 compounds. I mean, almost all of them are pretty dissimilar to non-actives. So you can see a little bit some of them. And what we will do now, we can swap with input. We will search those compounds, which are pretty different of non-active. We'll search if we can find them in a library which is not too big for the sake of the time of this demonstration, but you could actually search the entire PubChem if you like 24 million compounds. Here I will just search those molecules into molecular file which is from PubChem. They are all known actives, molecule entity that active in PubChem. It's something like 400,000 molecules. They are also aromatized. If you don't aromatize, then you will just get no hits. Okay, so I have that. I also skip the find multiple match. I choose an output file. So they are also saved on the disk. And I can launch that in the very same way as before. That will take some more time. You see that's like 200 and it has to go to 400,000. I stop the recording. The search into the PubChem active molecules is now finished. There are 376 matches that we can display in the molecule grid. So here we are. So we have the hits there, which are in PubChem annotated as active on any targets. We could actually check that later. And they are not similar to non-actives. We can actually make a file now containing all those matches. We can go to the first search matches that were molecule active on EGFR, so we can swap with input. So now they are on the left side. We can add they are 194. We can add now the other matches. They will be at the end. We have here on the matches, we have an ID about the PubChem compound ID. We can make some sort on that. Could identify. I actually have a compound in mind that I could search. Well, you can actually reproduce that results and look at all those compounds by yourself. We can actually maybe look at this compound, which is pretty different of what is known as actives. We can also actually calculate the ligand protein descriptors by using the PLP intermolecular term. So we can sort and get those ones which are the most potentially actives. You see that you can retrieve the, well, that's some known EGFRs, inhibitors, and we can maybe look at this one. We can visualize that in the 3D viewer. We can open the context and we can see where it is predicted to bind. We can remove the query ligand. Well, it's located close to the hinge. What we could do is to have a look to PubChem to see what kind of compound it is. The number is 607-1683. So this is the compound with an hydroxylamine function, and we can look at its activity inside that. And well, we can see that interestingly that it was identified in probably cellular assays for anti-cancer drug screening. So that's a way of identifying compound that had been already tested for some target that might be of some interest for testing in your case. And you can save all those compounds as compounds, hybrids. They are actually hybrids with known pose. That's actually a result which is very similar to that if you've tried to dock some compound, because at the end what you have is a list of compounds which are existing in a molecular library, and that you can actually visualize in 3D. We can take some of them here and visualize them in 3D, and you see all those compounds from PubChem which are docked in the reference frame of the query. So that's now up to you to figure out what kind of compound could be interesting to test for EGFR. Thank you for listening to that till the end, and I just remind you that there are 3 videos for the complete training on this fragment-based drug design protocol available from the MED-SuMo website.